So what have I drawn down here? So what I've drawn is an MDP and a particular trajectory through that MDP. So here the dots are states, and the little lines are sort of the actions that you took to move between those states and whatever reward you happen to pick up along the way. So I'm in some MDP, a Markov decision process, and I am moving through states, taking actions and receiving rewards, and I'm sort of moving through that. And that's kind of what we've been thinking about before, right? This is what the Bellman equation sort of captures for us. I'm going to be in a state, take an action, end up in the next state, I'm going to be getting rewards. I should accumulate all that and use that to update my estimate of the value of being in a particular state. Right? That all sound familiar?
That is a diagram of SAR, 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 SAR.
Right. This is SAR, 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 forever and ever. Now, we know how this works. One of us, probably both of us at some point or another, actually sort of explained the math behind here and how you would back up values and why this is a way to do learning. But in this space where we have these temporal abstractions, we have these options, we're actually violating everything that we know about MDPs. And I think it helps there to draw a slightly different picture. So because we have these temporally abstract options, we are not having very simple time steps, right? So here, kind of implicit in this is we're in a state, we take an action, and then we're in another state. We're in a state, we take an action, another state, so on and so forth. And how much time passes between visiting each of these states, Michael?
I'm going to call it one time step.
One time step, which I'm going to claim, you may not agree with this, might as well be the same thing as 0 time steps. In some sense, we treat the actions in an MDP as if they are instantaneous. And perhaps to drag on more of the computer science analogy, we treat them as if they are atomic.
Okay, I'm along with you for the atomic idea. I definitely am not along with you in the it takes 0 time idea. But I guess 0 time in the sense that there's no I don't know, there's no crack in it. There's no window that anything else can jump in. And that's really the idea of atomic. So I think we agree.
Yeah, I think we do agree. I mean, you're basically, we're picking constants. You want to call it 1, I want to call it 0. We can both
No, but
claim
that's like me saying T and F are the same thing. 0 and 1 are not the same thing.
They're the same thing within a constant.
Not a multiplicative constant.
Fair enough. The point here is that in some sense, atomic, instantaneous, what really is happening here is I was in a state, I took an action, I ended up in another state. Nothing else can happen. We treat that time step, it may be a year, it may be a day, but whatever it is, we treat them all as if they're the same, and we're just moving along. In fact, we talk about time steps. And implicit, I think, in the way we've been talking about time steps so far is that they're all the same length, whatever they are, which is why you can call them 1. As opposed to 7. It doesn't really matter. The fact is that I take this, there's an atomic action taken, I end up somewhere else. Nothing else happens in the middle. I can reason about everything. By contrast, once we have these options, I mean, think about this this picture up here. Think about the the northeast room. If I'm in this little pink state here, I just entered into the room, I'm going to get from here, the east door, to the south door in some amount of time. Right? It's going to be made up of atomic actions because all I really have is up, down, left, and right. And I don't know how long that's going to take. Let's say it takes 50 time steps. It doesn't really matter. It's going to take some number of time steps. But if I'm in this little space down here near the bottom, already near the door, that's going to take fewer time steps. So what I'm actually seeing with respect to the underlying MDP is I start in some state. I take one of these options. Some amount of time passes, often more than the single time step. And then I end up in another state. And then I take another option, I end up in another state, take another option, I end up in another state, and so on and so forth. And the amount of time that I spend in each option is variable, potentially, and is not necessarily at the same as the atomic actions that we had before.
Oh, interesting. Okay, so variable time steps.
Right.
So does that mess up everything?
It does, because if you think about the way Bellman works, is it assumes a discount that happens at every time step, and it accumulates information along the way. So we need to have a way to capture all of that that allows us to get all of the neat little features of an MDP while still allowing us to use these variable time actions. It turns out that's pretty straightforward to do. I'll just write out the equations for you, and hopefully it'll be easy to see.